Hello everyone and welcome to How To. This is an introductory video to sequence and series, which is one of the first topics that is covered in algebra. My name is Dina and I will be taking you through the rest of this video. Let's get started. This is the first of a series of 7 videos on the topic of sequence and series. In our other videos, we will take a more detailed look on arithmetic sequences, geometric sequences. We will define and learn to calculate series. We will look at finite arithmetic sequence and finite geometric sequence. And finally, we will end up with a video on infinite series. The videos are short and simple and to the point so that we grasp the concepts quickly. So let's get started by introducing the concepts of sequence and series. So what is a sequence and what is a series? Already when we hear the word sequence, we have some notion of what it means. We know it is some sort of pattern. If we have an apple, orange, banana, which is also followed by an apple, orange, and we do not know the last term or the last item in the sequence, we intuitively know it should be a banana. And that is a sequence. By definition, a sequence is said to be an ordered list of numbers where each of the following term is obtained by a fixed rule. A series is derived from a sequence and is said to be the sum of the terms within the sequence. Now that we have defined what a sequence is, let's take an example. Here we are given the numbers 2, 4, 6, 8, and 10. Immediately, we see that there is some sort of pattern associated with these numbers. We can see that the second term, 4, is derived by taking the first term, 2, and adding 2 to it. Similarly, the third term, 6, is derived by adding 2 to the second term. By continuously adding 2 to each of the terms that follow, we can get the fourth and fifth terms of this sequence, which is 8 and 10 respectively. So here we can say that the numbers 2, 4, 6, 8, and 10 is a sequence which starts at 2 and increases by 2 each time. Let's take another example. Here we're given the numbers 1, 4, 9, 16, and 25. Immediately we cannot see a pattern arising, but with further interrogation we can see that the second term is derived by taking 2 to the power of 2. The third term is derived by taking 3 to the power of 2. And the fourth and fifth terms are derived by taking the fourth term to the power of 2 and the fifth term to the power of 2 respectively. This is a sequence that starts at 1 and is followed by numbers raised to the power of 2. If we were to find the nth number or the nth term of the sequence, we will take the nth term and raise it to the power of 2. Let's take another example, but this time I would like you to take some time, pause the video and try it yourself. I would like you to calculate the first 4 terms of a sequence that is given by a subscript n equals 3n plus 2. Do it now. Welcome back, guys. I hope you all managed to get the answer. We see that this was a simple example and the sequence is given by a linear function because each term that followed increases by the same amount. So let's have a look at the solution. The solution is, the first term is calculated to be 5. The second term, 8. The third term is given by 11. And the fourth term is given by 14. So this is a sequence that starts at 5 and ends at 14. I hope you all got these answers. As a challenge, try and calculate the 100th term of the sequence. Let us follow up with series. So a series is derived by adding the terms or values in a given sequence. We can have both finite and infinite series. Finite means that there is a countable number of values or objects in that sequence that can be summed up, whereas infinite is the opposite and means that there is an endless number of terms or values in that series. A series is given by the following notation. The n represents the number of terms within the sequence. In this case, there is an infinite number of terms. The funny looking E symbol is a Greek letter which is also referred to as sigma. This sigma indicates or means summing up or addition of. Our series is bounded by a lower and upper limit. In this case, n is equal to 1 is the lower limit of the series, and infinity the upper limit. Let's take an example of series. Once again, we have the numbers 2, 4, 6, 8, and 10. So, by definition, adding or summing these numbers in this sequence, that is, adding 2 to 4, adding this to 6, and adding 8 and 10 results in the series. Let's take one more example. Once again, I would like you to pause the video and try this by yourself. Here, we're given the sequence 5, 8, 11, and 14. Let's find the series. Welcome back. So for this sequence, our series is the sum of the numbers 5, 8, 11, and 14, which in this case equals 38. Let's summarize what we have learned. I like to use the pizza example. I love using this example because students tend to relate to it and remember it easily. So you decide to buy yourself half a pizza. In the first hour, you eat half of the pizza. But you're still hungry. So in the next hour, you eat half of what is remaining. So in this case, a quarter of the pizza. And since the pizza was so delicious, you decide to eat half of what is left. That is, a half of a half of a half, or 1/8. You do this till you finish the pizza. In this case, the sequence of the first three terms is given by half, quarter, and 1/8. The series is the sum of these three terms in the sequence, which is a half plus 1/4 plus 1/8, which gives us 7/8. This means that by the third time you eat the pizza, you have eaten 7/8 of the pizza. In this example, the list of fractions of the pizza you ate is the sequence. And if you want to know how much of the pizza you ate altogether, you create a series or a sum. So I just want to reiterate this so that we can simply understand the difference between sequence and series. So the fixed manner in which you ate the pizza defines your sequence, and how much of the pizza you've eaten altogether defines your series. So keep that in mind. Let's quickly recap what we have learned. We know that a sequence is a defined list of numbers or objects in a special order. And a series is derived from a sequence and is the sum of the values in the sequence. Thank you for watching, everyone. Hope you understand the basics of sequence and series. We have a number of videos on the topic. Our next video will be on arithmetic sequence, followed by geometric sequence, and so on. By the end of this video series, you'll be fully equipped to tackle any questions on sequence and series. Watch out for my next video, and please don't forget to like, comment, and subscribe. Thank you.